Hello vintage computer friends, and now here is the follow-up to my previous video where we measured the speed, the raw compute power in terms of MIPS or million instructions per second on the Bosch Microtronic 1981 4-bit computer system, and now we are continuing and compare this with the 1983 Kosmos CP1 educational computer system, also from West Germany. So how will this MIPS Monster compare to the Microtronic? And remember that in my previous videos I gave you a hands-on programming experience with this machine, and we already got the impression that this machine is quite a bit faster than the Microtronic. And we looked at this in my deep dive video about the Kosmos CP1. So it's an 8049, which is running this masked programmed ROM containing the monitor and the emulator for this virtual machine language, very similar to the Bosch Microtronic, but of course it's an entirely different CPU microcontroller, and it's clocked at 6 MHz, which is much faster than the 500 kHz that the Microtronic is equipped with. And of course it's also an 8-bit microcontroller, whereas the TMS 1600 was only a 4-bit microcontroller. So yeah, but I mean, given that all of this is emulated, the question really is how much performance is lost, of course, based on the emulation. And so we are going to perform the same experiment that we did with the Microtronic. We have the oscilloscope hooked up black to ground, and here this is bit 1, or depending on how you count, right, the lowest significant bit of the second output port, and the output ports are 8-bit on the CP1. So we have one input output port here, and this is the second output only port. Okay, so let's look at the program that I already entered here. And so program started address 01, and we see that the first opcode is 04, which means load a constant into the accumulator. And here we are loading 0 into the accumulator. And now to output the value that's currently in the accumulator to digital output port 2, opcode 18 is used. And then you can either specify 0, then it would basically output all the bits, or you can only specify which bit you want to output. In this case the accumulator can only be 0 or 1. And here we are outputting now the bit 1 basically to the output port, but we could also output, as with the Microtronic, load an 8-bit value into the register and it would output the correct bit pattern, right? And next we are loading 1 into the accumulator, and then we are again outputting this to bit 1 at port 2. And 09 is just an unconditional jump, go to 01, program starts over. So let's actually run this program. We are setting the program counter to address 1, and then we hit run. And wow, there we have our square wave on the oscilloscope. Let's see if we can auto set this and center this a little bit. Maybe adjust the position a little bit. And you can see what the oscilloscope is telling us about the frequency. Let me zoom in here, you can see it better. Let's use this value here, 643 Hertz. Okay, and again, in order to get the number of instructions that are performed per second, we now have to multiply this by the number of opcodes that we needed in order to reproduce the 1, right? And let me stop the program. And how many instructions did we need? So 1, 2, 3, 4, and then there's a goto, so 5 instructions. So let's multiply the values that we got, the average Hertz number that we observed, which was 643 by 5. And if we do this, 643 times 5 is 3115 instructions per second. Well, that's quite a bit, I must say. I'm surprised that this machine is so much faster. So comparing this to the Microtronic, which maximally had like 114, right? So we conclude that the CP1 is about 28 times faster than the Microtronic. and that's quite a bit faster than I anticipated. I expected like a factor of 10 or 12, but let's also calculate this emulation overhead factor. So if this machine is clocked at 6 megahertz, right, natively, let's divide this by 5 times 643, and we see that the emulation overhead is 1866. It's also quite a bit lower than what we had for the Microtronic. For the Microtronic, the overhead was, I think, 4200 or something like this. Yeah, so that machine is running much faster than the Microtronic, and for physical computing that requires higher frequencies at the input-output ports, it's of course the machine of choice. Yeah, but still it's an emulated virtual machine language, and I'm looking forward to getting the number for one more educational computer system from West Germany from 1984, the Philips Master Lab, which does not use a emulated machine language, but can be programmed in native SCMP instruction set, right? So that's going to be the next video then. Until then, stay tuned and thanks for watching.